today we are gonna do another question, which is um, the resultant vector R of two vectors vector E and vector B is perpendicular to the vector A to the vector A to vector, I don't think you need the, so to vector E, and its its magnitude is equal to half of the magnitude of the vector B. So of vector B, let's just write of vector B. Find out angle angle between vector A and vector B. So we need to find out the angle between vector A and vector B, which might sound simple or which might sound complex as well. So let's see what we have. So we have the resultant of vector A and B to be vector R, and which is perpendicular to vector A, and its magnitude is equal to half the magnitude of vector B. So that's the thing that we have. So we know that phi, which is the angle between R and A, is 90 degrees, and the magnitude of the resultant is half of B. So, right? So let's see the figure. It's gonna be a right angle triangle, and it's gonna look something like this. So let's create the vectors. Let's make this vector some other color and a lot more thicker, and I'm gonna first of all create some vectors, and we're gonna check out what they are and what they are meant to be. So this is gonna be blue, blue. The figure is not to scale, obviously, right? I think you should know that. So let's say this is vector E, then that means that this must be vector R, or the resultant, and this must be vector B. So the blue one must be vector B. So just looking at the picture, we need to find that what is the angle between vector A and vector B. So if you check this out, let me ask you a question. Is this the angle between vector A and B? Is this the angle between vector A and B? No, this is not the angle between vector A and B, right? So this is not the angle between vector A and B, because you must use either the tail method or the head method. So let's say that what's the tail method? So I will have to parallelly transform this A vector like this, so that it is connected by tail method, right, like that, or I will have to move this vector downwards so that it's connected to by head method. So you can use either tail method or head method. So I'm going to use tail method, and let's make this a dotted, and also make this of a different color, since this should not look like a vector. I'm just projecting it. So the angle that we need is actually this, right? So this is the angle that we need, and this angle is just 180 degrees minus alpha. But we are not going to use theta as the angle that we need. We're actually going to use alpha, since alpha is going to give us a much more range to work with. So I'm going to use alpha, and obviously when using alpha, the obvious question is, what trigonometric, what do you use? So before that, let's actually label each of them. So what is the perpendicular, what is the hypotenuse, what is the base? The simplest one is the longest side is going to be the hypotenuse. So this is going to be the hypotenuse. The shortest side, it does not matter the short side. The side connected to the angle is going to be the base. So this is the base. And finally, the that is not connected to the angle, the side that is not connected to the angle is going to be the perpendicular, right? Since it is perpendicular to the base. I think this is easy. Now let's think of a relation which we can use. We know that the resultant and the vector B are connected. by r equals to b by 2, which means if we have an equation that uses p and h as a trigonometric ratio that uses p and h, that will be the golden goose. That will be the thing that we need. And I know what is p by h. So we know sine theta is p by h, perpendicular by hypotenuse. Um, so the perpendicular right now is the resultant, and the hypotenuse is b, right? So we are only writing the magnitudes, since the direction does not matter when you're using these stuff. So the resultant can also be written as b by 2, and obviously we have 1/2 b. Now the b's will cancel out, right? So we have sine theta to be 1/2. We have sine theta to be 1/2. Now sine theta is 1/2 only when sine is 30 degrees, which means theta must be 30 degrees, right? But is this theta we're talking about? Of course not. We're talking about alpha, right? So everything must be written in terms of alpha. So this is alpha, this is alpha, this is alpha. And is the alpha the angle that we need? No, alpha is not the angle that we need. We need theta. So theta is actually 180 degrees minus alpha. So 180 degrees minus 30 degrees is going to be 150 degrees. So 150 degrees is the answer. So to conclude this, therefore the angle between vector A and vector B is 150 degrees. I think that's a perfectly easy question. This is a very easy question once you know what to do. But if you don't know what to do, this might be kind of difficult. But this is going to be it for today's video. On the next video, we are going to talk about another question. So till then, bye bye.